So remember, there are different ways to factor. Factoring can involve a GCF. Factoring can involve a difference of squares. Factoring can involve grouping. And some quadratics are not factorable at all. So in example number 1, that very first thing you should do is pull out a factor of 4. So in number 1, we say that 4 is the GCF. So we bring 4 out in front. And then you look at the remaining quadratic. And you say, okay, what are the factors of -3 that sum to 5? Well, there are no factors of -3 that sum to 5 because the only factors of 3 are 3 and 1. And no matter what way you multiply them, you will not get 5. So in number 1, we are done. The only way to factor that is to factor out a GCF. In number 2, we have 9x squared minus 21x. This is a binomial, meaning that there are only 2 terms. So once again, we are looking for a difference of squares or a GCF. In this case, it is a GCF. My GCF is 3x. So I take out a factor of 3x, leaving behind 3x minus 7. Those are considered factored expressions. So again, up to this point, everything we have been looking at is an expression. The difference between an expression and an equation is an equal sign. So now we are going to start mixing in problems with equal signs. So we're in chapter 5, section 3, and now our goal is to solve. So that being said, we're going to introduce something known as the zero product property. The zero product property says if a product of real numbers is 0, then at least one of their factors is 0. So the short definition of that is that if A times B equals 0, then A equals 0, B equals 0, or A times B equals 0. Okay. So an example of that is taking something like where we were yesterday. So we were at factored form. So in this example here, 2a plus 4 times a plus 7 is in factored form. What is new is that it is now equal to 0. So up to this point, we have not had equal signs. So now it is new. It is equal to 0. The zero product property tells me that if 2a plus 4 times a plus 7 is equal to 0, then this is kind of like my A. This is kind of like my B. So A is equal to 0 or B is equal to 0, meaning 2A plus 4 is equal to 0 or A plus 7 is equal to 0. What I want to know is what is the value of A that makes that answer 0. So we're going to go back to lesson 3 from chapter 1, which is solving equations, and solve for A. So 2A equals -4 or A equals -7. Divide both sides by 2. And we get A is equal to -2 or A is equal to +7. I mean, -7, sorry. Barely my asking. So that is what we are adding to our lesson. That's it. So it's kind of like everything you had to know how to do yesterday, which is to get to this point here. And now taking it one step further, which is solving for the variable. That being said, the steps we followed previously are going to change a little bit. Now we have this step 1. Step 1 is that we have to arrange the terms so that they are equal to 0. Before, we just had to arrange the terms so they went x squared xc, and most of them were already in that form. Now we have to make sure it goes x squared xc equals 0. So the equation must be set equal to 0. X squared must come first. The x term must be in the middle, and the c at the end. Step 2, parts 1 through 4, are old. That is what we've been doing. So step 2 is what we've been doing. That is old. So what is new is now steps 1, 3, and 4. So set equal to 0, do what we've been doing, then take the answers that we previously got, set them equal to 0, and then solve them. So for the next example, I'm going to walk you through it, following the steps, and then from there on out, we'll do them just applying the steps. Okay? So example number 1, we have 3x squared minus x equals 10. Is that currently set equal to 0? No. So we have to subtract 10 to the other side. You must get it set equal to 0. So we're going to subtract 10 from both sides. So that makes my new equation 3x squared minus x minus 10 equals 0. Step 2 is the old stuff. So you're going to do multiply the first times the last to fill in your magic x. The middle is the bottom of the magic x. So I need two numbers that multiply to -30 and add to -1. So two numbers that multiply to -30 and add to -1. Go ahead.
-6 and 5.
Perfect. So my two numbers are -6 and +5. So we're going to take those two numbers and replace the middle. Then you're going to group the first two group the last two and take out their GCF. So the GCF of 3 and 6 is 3, of x squared and x is x, and the GCF of 5x and 10 is 5. So I take out a 3x and a 5, and that leaves behind an x minus 2. So in factored form, I have 3x plus 5, quantity x minus 2. One thing you need to know or pay close attention to is the fact that now on each of these lines, I am writing equals 0. You must write equals 0 on every step of the way. You must write equals 0 every step of the way, or you'll lose a point. Once you're in factored form equal to 0, you take the first factor and set it equal to 0, and the second factor, set it equal to 0, and solve for x. So you have x minus 2 equals 0, and 3x plus 5 is equal to 0, thus giving x equals 2, and x equals negative 5/3, because you subtract over the 5, divide by 3. Questions? Comments? Concerns? One. Number 2. X squared minus 27 equals 6x. Step 1. Get it set equal to 0. And make sure we are in standard form. Your terms must go x squared, then x, then c. They must go x squared, then x, then no x's. So when we subtract over 6x, we need to make sure we stick it in the middle. So once again, two numbers that multiply to negative 27 and add to negative 6. Multiply to negative 27 and add negative 9. Perfect. Negative 9 and positive 3. Group the first two, group the last two, take out your GCF, get it into factored form, set each factor equal to 0, solve for x. So negative 3 and positive 9. Those are the roots, the solutions, the zeros. Where it crosses the x-axis, those are my answers. Once again, it is not in standard form or set equal to 0. So the very first thing we're going to do on any solving quadratic equations problems is get it set equal to 0. So I'm going to add that 5x over, and when I add it over, I'm going to smush it in the middle so that my terms go in order. And then once again, to factor, I'm going to multiply the first and the last to add to the middle. So I need two numbers that multiply to -6, but add to +1. Okay? Yep. So I'm going to use 6 and -1, because 6 minus 1 is 5. 6 times -1 is -6. So when I do this, I'm going to group the -1 and the 2x together, just so I don't have to take a GCF out of a negative term. So my GCF at the front is an x, leaving 2x minus 1. The next terms is a 3, leaving 2x minus 1. So in factored form, I have x plus 3, 2x minus 1, set equal to 0. Setting each factor equal to 0, you have x plus 3 equal to 0. More x plus something equal to something. Subtract 3 from both sides. You get x equals -3. And over here, 2x minus 1 equals 0. Add 1 to both sides. And then you have 2x equals 1. To get x alone, you divide both sides by 2, giving x equals 1/2. Yes.
For like when we hit the x plus 3 is equal to 0, we have to actually show what for that.
Yeah. And then the last case, in this example, I have 2x squared plus 8x equals 0. So it's set equal to 0. So step 1 is done. Now I need to factor it. But what happens here is my C value is 0. So if the C value is 0, what am I looking for? And only looking for? There is no C term. I am only looking for one thing in this problem. A GCF. If there is no C, the only thing I can do is take out a GCF. So 2 and 8 both divide by 2. X squared and x both have an x in common. So the GCF of 2x squared plus 8x is 2x, leaving behind x plus 4. So if you have two terms and the C term is non-existent, you are looking for a GCF. Same rules apply. This is my A, this is my B. So the zero product property says A equals 0 or b equals 0, or both. So 2x equals 0 or x plus 4 equals 0. Well, 2 times what number is 0?
0.
0. So x must equal 0 as one of my answers. Subtract 4, and my other answer is x equals -4. 2 answers for almost all of them. Why? Because it's a quadratic. Quadratics typically have 2 answers. Keywords are typically.